Hello everyone, my name is Raghavi Priya, Assistant Professor, Department of Computer Science and Engineering. So in this video, you're going to see about object-oriented programming concept. So unveiling object-oriented programming. So explore the foundational principles that empower developers to build robust, scalable and maintainable software systems. So the agenda of this presentation is we are going to see about the core pillars of object-oriented programming. So objects, the building blocks, classes, blueprint for objects, encapsulation, data protection, inheritance, code reusability, polymorphism, flexibility in action, abstract classes and interfaces, then concluding thoughts and next steps. So objects, the fundamental building blocks. So what is an object? An object is a self-contained entity representing a real-world concept or a component within a system. It combines both data, attributes and behavior methods into a single unit. So think of a car. It has attributes like color and make and behaviors like accelerating and braking. So key attributes of an object. So the key attributes of an object are state, behavior and identity. So state, which is also known as attributes, so it contains the property or data that describe the object. For example, a dog object might have attributes like name, breed and age. So next one is behavior, which is also known as the methods, action an object can perform. So a dog object's methods could include bark function, fetch function or sleep function. So next one is identity. Each object is unique even if it has the same state or another object. It has a distinct memory address. So creating and using objects. So instantiation, objects are created or instantiated from classes. A class acts as a blueprint and an object is a concrete realization of that blueprint. So in Java, dog my Java equal to new dog of we are giving an attributes. So next one is object interaction. So object communicate by sending messages, calling methods to each other. This modular interaction promotes maintainability. So my dog dot bark, calling a method string name equal to my dot get name, accessing an attribute. So the ability to create and manage multiple instances of object is fundamental to OOP's power. So next one is advantages of object-oriented design. So there are many advantages using OOP's concept. So we are going to see about 4 advantages. First one is modularity. So object encapsulate concerns, making code easier to understand, manage and debug. Problems are isolated. Reusability. Classes and objects can be reused across different parts of an application or in new projects, saving development time. So maintainability. Changes in one's object's internal implementation typically don't affect others, simplifying updates and reducing side effects. Next one is scalability. Adding new features or expanding functionality often means creating a new object or classes rather than rewriting existing code. So objects in real world systems. From operating system to web applications, objects are everywhere. So user interfaces such as buttons, text fields and windows are all objects. So databases, records and tables can be modeled as objects. Gaming, characters, items and environments are distinct objects. IoT devices, sensors, actuators and communication modules are treated as objects. So OOPS provides a natural way to model complex system, bridging the gap between real-world entities and software constructs. So the key takeaways and next steps are object as code. Understanding that objects are fundamental unit encapsulating data and behavior. Benefits: appreciate how objects lead to modular, reusable, and maintainable code bases. Practical applications such as start identifying objects in everyday scenarios and consider how you might model them in code. Thank you.